Hey, Math 1. We're going to take a look at the even solutions, the even numbered solutions to the 2.1 through 2.6 quiz review. I believe it says quiz number 2 review at the top. So, check your answers. Make sure that you guys have the little details down for this quiz. So our first one is 13 minus 5x is equal to negative 22. It's a very quick two-step process. I have a positive 13 that needs to move over to the negative 22. So I've been preaching this all throughout class. If I were you, I'd get a highlighter and make sure you highlight the fact that 13 has to be moved to the negative 22. You can't call 13 minus 5x 8x. So subtract the 13 here, subtract the 13 there. 0 minus 5x equals a negative 22 minus 13. Same sign means add the two. And make sure you keep the sign of it. So there's our first step. Second step is to divide out that negative 5 to create a clean 1x. You're dividing the right-hand side by negative 5. Make sure you recognize that a negative divided by a negative yields a positive value. Okay? Negative divided by negative is a positive. 35 divided by 5 is 7. Number 4. Again, fairly simple equation. All we got to do is collect the 4x and the negative 6x. All right, this is where I would highlight those two the same color. So in fact, why don't I just do that right now? Maybe you can't see it so much on the video, but it's just the principle of it all, right? So I'm going to say, with my blue highlighter, I've got plus 4x on the left and minus 6x on the right. With my green highlighter, I've got 4 on the right and 5 on the left. So hopefully that would be helpful to say, hey, the blues go together. Add 6x to the right to zero that out. Add 6x to the left. Make sure that the 4x and the 6x are coming together. And then you want to move this green 5 to the other side. I told you you guys could use that shortcut if you feel like you can handle it without making a bunch of mistakes. All right? So I can do both of those, the blue step and the green step, at the same time. If you feel like that's a bad idea, you need to separate those steps, by all means, please keep doing it that way. The left-hand side gives me a blue 10x. The right-hand side gives me a green negative 1. At this point, we can divide by 10 on both sides. All right, this is oftentimes a common mistake among students. Students will think that, hey, negative 1 over 10, 10 or negative 10. But here's the deal. You can't simplify a fraction any further if the numerator is 1. If the numerator is 1, you're done. Hey, that's kind of catchy. If the numerator is 1, then you're done. Sorry guys, I'm trying to scroll down. I'm having some problems with Word right now. Give me a second. Okay, sorry about that. All right, on number 6, we're asked what to do when we have decimals everywhere. Multiply both sides by 10. When you multiply by 10, you either add a 0 to it or you move that to the right. Move the decimal point to the right. So I'm increasing by a power of 10, 17x. I'm increasing by a power of 10, negative 30. Increasing by a power of 10, 14x. And increasing by a power of 10, minus 72. I think that makes things a lot easier for us because we now have our blue highlighted x terms and our green highlighted y terms. All right, I didn't do any moves. I highlighted things. Yeah. So then blue goes with blue. 3x minus 30 equals negative 72. Green goes with green. Add 30 to both sides. So 3x is equal to, let's see, negative 72 plus 30. Opposite signs subtract. So 72 minus 30 is 42. And then you take the sign of the bigger value and then divide everything by 3. So if you got to go inside the box to figure out what that quotient is, then please do that. 3 goes into 4 one time. Subtract, you get 1. Drop the 2. 3 goes into 12 exactly 4 times. So it's 14. A negative divided by a positive would yield a negative value. So x equals negative 14. Number 8. Things are escalating a little bit. We have to deal with parentheses on both sides. This is a great one to talk about because a lot of people get confused when they have to distribute just a plus or just a minus. I'm here to clarify that. If you're distributing a plus to something, think of it like this. A positive times a positive is a positive. A positive times a negative is a negative. So the plus leaves everything in the group unchanged as far as its signs are concerned. Notice I didn't multiply by 3x. It's 3x plus everything in the group. So the 3x just drops down. So I've got the 3x, I've got this grouping symbol. I'm going to put a minus 2 here. There's my left-hand side. All right, this negative here gets distributed to a positive 3x, which makes it a minus 3x. A negative times a positive 7 is a negative 7. And make sure you bring down the positive 6 that was there and the negative 5x. All right, this is where you guys take out the highlighters and say the 3x and the minus 4x, since they're on the same side, has to just complement. I have to just take 3x minus 4x. I don't add 4x to both parts. I just do 3x minus 4x. It's negative 1x. Same deal with the constants. I've got a plus 5 and a minus 2. That's 5 minus 2. That's a positive 3. Do the same thing on the other side. Let's see, I'm going to keep things consistent here. Negative 3x minus 5x is going to be a negative 8x. Positive 6 minus 7 is going to be negative 1. So, red term goes with red term. I'm going to add 1 to both sides to get the red constants together. Now I'm going to get the purple x terms together as well. So I'm going to add this 1x to both sides. And here's what I want. I want a constant on one side and an x terms on the other. That's why I didn't add 8x. I want to keep it like this. So, we got a 4 on the left, negative 8 plus 1, opposites subtract. Take the sign of the bigger one. Yeah, and then you divide by negative 7. So x equals negative 4/7. Check out number 10. Looks simple enough. I've got grouping symbols on the right that we need to get rid of. 3 times 7x is 21x. 3 times negative 4 is negative 12. Just drop down the 5x minus 12. Make sure you're keeping in mind that I want to bring the 5x to the 21x. Those are the only two terms that can combine with one another. So since they're on opposite sides of the equation, I'm going to subtract 5x from both sides. And you know, at the same time, I think I want to move this negative 12 to the left as well. So I'm going to add 12 to this so that I can add it to over here. All right, so I've canceled my constants on the right. I've canceled my x's on the left. I'm left with negative 12 plus 12, opposites subtract. That's 0. 21x minus 5x is positive 16x. Now, here's the main question a lot of students have. Is this no solution? That's one of the special cases. Is it all real numbers? Or is it x equals 0? Well, these two will only occur if your x's drop out. That's like when you have a 0x and only a 0x. I have a 16x. I'm supposed to divide by 16. 0 divided by 16 is still 0. All right, number 12, we're moving right along. All right, a lot of people had questions about these kind of fractions. So keep in mind, if there's a negative out front, the first thing I'm going to do is assign the negative to the top part. I'm just going to put it right there in the numerator. The second thing to keep in mind is that we're able to rewrite fractions any way that pleases us as long as we're consistent and proportional. What I mean by that is, if you guys had the fraction 3 over 12 equals 1/4, which is a true statement, okay? 3 over 12 equals 1/4. I'm allowed to flip the first fraction and set it equal to the second fraction flipped. That checks out. 12 divided by 3 is 4. 4 divided by 1 is also 4. You can also take the top divided by the top, and it should yield the exact same value of the bottom divided by the bottom. Yeah, I can create a totally new equation that's much more manageable by just taking the top left and rewriting it as divided by the bottom. Dividing it by the top right. All right, so I took this, divided it by negative 7. That should equal the bottom right, 2 plus 7x divided by 5. So sometimes that can be a little bit confusing, but if I rewrite it like that, then I can find a common denominator of negative 35. I can multiply the first one times 5 on both the top and the bottom. And I can multiply the second by negative 7 on both the top and the bottom. So now they both have a common denominator of negative 35. In the numerator, I can take 5 times 3x, 15x, 5 times negative 3, minus 15. Negative 7 times 2 is negative 14, and negative 7 times 7x is minus 49x. Once you have the same denominators, you can ditch the denominators and just solve the top. So again, I take out my highlighter and I highlight this x term and this x term. I'm telling myself, hey, maybe add the 49x to the right and to the left. Cancels out the x terms. At the same time, I can cancel out the constant negative 15 on the left. Add it to the right-hand side. Now you've got 14, carry the 1. 4 plus 1 is 5, plus 1 more is... You got 64x on the left, and you've got opposites subtract, and negative 14 plus 15 is equal to 1. Take the sign of the bigger one. Yeah, divide by 64. If the numerator is 1, you're done. All right, everybody, we're nearing the last two problems, so I know we're over 16 minutes right now on the video, but hold on. The end is soon. So maybe the most complex problem on this entire problem set is looking at you right now. What I want to do is create 4 fractions with the same denominator. But before I can do that, I want to clean it up a little bit. So this 5 1/3, I want to make that into an improper fraction. So I'm going to take the 5 whole number times the denominator. That's 15 thirds, okay? 5 is 15 thirds. Add 1. That's going to be 16 thirds. I'm not going to do anything different with this fraction. I'm going to actually put this x that's just resting beside the 1/6. 1/6 times x is the same as 1x over 6. I think that's a helpful thing to do. All right, now you ask yourself, what is the common denominator that 3, 4, 6, and 12 all go into? 3, 6, 9, 12. 4, 8, 12. 6, 12. They're all members of the 12 family. So think about this. I want to put something over 12, something over 12, something over 12, and something over 12. So 3 times 4 gives me 12, so I multiply the top times 4. 16 times 4 ends up being 64. Okay? This is the tough part. 4 times 3 gives me 12. When I multiply the top by 3, it is going to adopt this negative that's in between the fractions. It's adopting the negative right here. So that's a negative 3 times x minus 2. 6 times 2 is 12. So I'm going to take 1x times 2, which is 2x. Let's keep consistent with the colors here. And then this is what it is, but again, very tricky part. This minus is subtracting the entire fraction. It's subtracting both 5 and negative x. So I really got to say it's negative 5 minus negative x. That turns into a plus 1x. All right, now that we've got the same denominator, we can ditch the denominator. And you know what? I need a little more space, so come on over here with me. There we go. And we're going to rewrite what we had over here. So you can kind of see that. I've got 64. I'm going to distribute this negative 3 right now. Minus 3x. A negative 3 times a negative 2 is plus 6. That equals 2x minus 5 plus 1x. Remember, we already distributed that negative, so we can just rewrite this as is. Okay, I'm going to highlight the 64 and the 6. 64 plus 6, because they're on the same side of the equation, I just add as is. 70. Keep the minus 3x. Yeah. Now I'm going to highlight the 1x and the 2x, and I'm going to just add them. That's 3x minus 5. Again, take your highlighter out. Highlight the 3x and the negative 3x. I'm going to add 3x to both sides here. That cancels it on the left, but gives me 6x on the right. And now I'm going to highlight the negative 5 with the 70. Okay, these are like terms. I got to move it from one side to the other, so I'm going to add 5. Add 5, cancels it on the right. 70 plus 5 is 75. And then you just divide by 6. So I'm going to rewrite it with the x on the left, the 75 over 6 on the right. You know what? I'm just going to go to the box and figure out how many times 6 goes into 75. Subtract, bring it down. 6 goes into 15 twice, which gives me 12. There's 3 left over. So 3 over 6. That's a half. It's 12 and a half. All right, last one. All right, so this is a throwback from the very beginning of the chapter when we were using sort of like our, like the flow of proof writing from chapter 1 to really understand how equations should be solved and documented on a step-by-step basis. So up here above this, you guys have the, like the, what do you call those? It's not a key, it's a bank. It's a bank of properties. So you started off with your given here. On the next line, the parentheses have completely disappeared. Using multiplication to get rid of the parentheses is the distributive property. I'll just use shortcuts here, little abbreviations. So, took care of that. On the next line, it looks like I got the like terms side by side on the left-hand side. That's the commutative property. Then on this line, it looks like I took 3 minus 7 minus 40. I calculated that and got negative 44. 4x minus 2x is a positive 2x. If you recall, that was a substitution property from our combining like terms proof. I'm not just going to put sub because there's a subtraction property. All right, so I took the extra 4 seconds to write substitution. Now, line 4 is just this move right here. This is one of those properties of equality where you do something to both sides of the equation. I added, it's the addition property of equality. And technically, I don't know, nothing, I'm not asking you to document the calculation on this line, but from that line to the next, instead of adding, I'm subtracting. So that would be the subtraction property of equality. And then I'm dividing both sides by 6. That's the division property of equality. I don't know if you guys got this feeling, but I feel like this one's a lot more intuitive. It's kind of natural to say, he added. That's the addition property. It's a lot easier than trying to wade your way through additive inverse versus additive identity. So hopefully that encourages you. All right, and then the last one, this can be a little bit confusing because it's like you got your answer, but then you rewrote it. Why? Well, I'm trying to test your ability to recognize that when I rewrite the left and right hand sides of the equation flipped, that's called the symmetric property. So make sure you guys have at least a bare minimum understanding of the properties so that you can fill out a proof like this. All right, this is a 26-minute video. Thank you so much for your patience and enduring this to the end. Hopefully it was helpful, good study resource, and good luck on the quiz tomorrow. I'm rooting for every single one of you. All right, thanks for watching.